Okay, in a previous video we learned about how pH changes in a titration, and we saw that depending on whether the titration involved a strong acid versus a strong base, or a strong acid versus a weak base, or a weak acid versus a strong base, the pH at the equivalence point is going to be different. And what we saw is that at the equivalence point there is only water and a salt, and so what affects the pH at the equivalence point is actually the pH of the salt. Some salts are neutral, some salts are acidic, and some are basic. And in today's video we're going to learn about the pH of salts and why certain salts are acidic, basic, or neutral. Now before we launch into this, we need to revise a few concepts. The first concept that we need to revise is the concept of acid-base conjugate pairs. If we have an acid, to work out its conjugate base, all we've got to do is take away H+. So an example of an acid is H2SO4. Its conjugate base is going to be HSO4 minus. I've just taken away one H+. On the other hand, if I've got a base and I want its conjugate acid, all I've got to do is add H+. So an example of a base is ammonia. Its conjugate acid would be NH4+. So to go from the acid to the conjugate base, we take away H+. To go from the base to the conjugate acid, we add H+. Another important idea is that the conjugate base of a strong acid is a very, very weak base that does not interact with water to any significant extent. So an example of a strong acid would be HCl. The conjugate base of HCl is Cl-. So if I put some chloride ions in water, nothing much is going to happen. The chloride ions are not going to interact with water to any significant extent. Now on the other hand, an example of a weak acid would be acetic acid. Its conjugate base is the acetate ion. And when I put the acetate in water, it does interact with the water to produce molecules of acetic acid and hydroxide ions. The table that I've got on this slide over here explains this a little bit better. So what we can see is that there's a continuum from the strongest acids at the top of this table, and obviously this table does not list every single acid known, it just lists some common acid. So we've got the strongest acids at the top of the table and the weakest ones at the bottom, and we can see that the stronger the acid is, the weaker its conjugate base. Now the acids and bases that I've highlighted are the ones that we're likely to come across in the HSC course. Okay, and for the sake of simplicity, we can basically consider that anything above this line, we can consider that to be a strong acid, and anything that's below the line, we're going to consider that to be a weak acid. Okay, so basically anything above the line, we can pretty much assume that the conjugate base does not really interact with water to any significant extent, but the ones that are below the line, then yes, their conjugate base is going to interact with water to produce hydroxide ion. Okay, the next thing that you need to do is you need to actually make a start on page 19 of your OneNote. You've got a link to an interactivity, which I'm going to open in a little while to show you how that works. And what you need to do is measure the pH of some salts. Now, okay, so I've got the interactivity open. So you'll need to select salt. We're going to start with the first salt on the list, so that's sodium chloride. Now, at the moment it's set to 20 mils, you can leave that. And we're going to change the volume to, we're going to change the molarity, sorry, to 0.1 moles per litre. You can see that I've got a pH of 7. Okay, so what I'd like you to do is to keep the same molarity. It actually doesn't matter which molarity you choose, but can you make sure that you stick with the same molarity for all of the salts. The volume doesn't matter, so for convenience just leave it on the lowest volume, and then you've got to enter the pH value for all the salts into the table. Okay, so after you finish entering the pH values for all the salts, the next step will be to try and explain why the salts are either acidic, basic, or neutral. Now I'm going to work through a few examples with you, and then I'd like you to have a go at doing the others by yourself. I have supplied you with some answers, but I really would like you to try and have a go at working this out by yourself before just copying the answers. Okay, so I've got 3 examples on the screen here. So the first thing you're going to have to do is you're going to have to think about which anion and cation are produced when that salt is in water. So if we've got sodium chloride, the cation is going to be sodium ions, and the cation is going to be chloride ions. Now, sodium ions in water, sodium's not the conjugate acid or base of anything. So when we have sodium ions in water, they're not actually going to interact with water in any significant way. So does this cation interact with water? No, it doesn't. Okay, chloride ions, on the other hand, they are the conjugate base of HCl. But if we keep in mind that HCl is a strong acid, chloride ions are going to be a very, very weak base that doesn't interact with water to any significant extent. So the answer again is no. So neither the cation or the chloride ion interact with water to produce either hydronium or hydroxide ions, so we would expect the pH to be neutral. And then to fill in the last column, to make this salt, which acid and base would you combine? Well, if I'm trying to make sodium chloride, a way that I could do that is I could combine sodium hydroxide and HCl. Okay, it's a strong base with a strong acid. So we're getting a neutral salt. That's exactly what we would expect. Okay, the next example is ammonium nitrate. Now, ammonium nitrate is made up of the ammonium ion and the nitrate ion. I might actually fill in the last column first. To make ammonium nitrate, the 2 substances that we would combine is ammonia, which ammonia you can write as either NH3, or you could also write it down as NH4OH, because when you put ammonia in water, it forms NH4OH anyway. The other substance that you would combine it with is nitric acid. Okay, now this time we've got a strong acid with a weak base, so we would expect the pH to be in the acidic range, and that's actually what we find. Let's work out why. Okay, the nitrate ion, that's the conjugate base of a strong acid. So because it's a conjugate base of a strong acid, it does not interact with water to any significant extent to produce either hydronium or hydroxide ions. The ammonium ion, that's a conjugate acid of a weak base. So it's a conjugate acid of ammonia, which is, ammonia is a weak base. So the ammonium ion is going to be a weak acid that is going to interact with water. And it interacts in water in this way. And you can see that hydronium ions are produced. Okay, so we've got an anion that doesn't produce either hydroxide or hydronium ions, and we've got a cation that produces hydronium ions. So overall, we've got hydronium ions that are produced, so that's why it's acidic. Okay, the last example that I'll do with you is sodium acetate. Sodium acetate is a basic salt, and we would expect that to be the case because to produce sodium acetate, we'd combine sodium hydroxide, which is a strong base, plus acetic acid, which is a weak acid. So we would expect the salt to be basic. Now let's find out why. Okay, so first of all, the sodium ion. Sodium is not the conjugate of either a strong, it's not a conjugate acid or base, so it doesn't interact with water in any significant way. The acetate ion, on the other hand, and I'm writing it a little bit differently, but that means the same as that. Okay, the acetate ion, on the other hand, it does interact with water. It's a conjugate base of a weak acid, so it will act as a base in water in this way. Okay, so I've basically completed the first 3 rows of the table for you. What I'd like you to do is to have a go at doing the rest of the table. I have provided you with some answers. I've sent the answers on the next page, but I'd like you to have a go at doing as many of these independently. So if need be, have a go, check the next page to see if you're getting right, and then come back to it and see if you can do more of it individually.